What are waves? I want quick responses. What are waves? Any guesses? So you might be basically sitting around, let's say, an ocean, right? Or yes, thumbs up.
सर क्या कहते हैं वाटर का एक लेवल्स बढ़ रही हूँ लाइक एक
Hmm. That's good, right? So you basically observe near ocean or seaside, you observe waves over here, right? So let's say if you are taking, let's say a shower, you might be playing with the bucket, right? If you, let's say, punch in your bucket, you basically produce waves, right? So for producing waves, what do we need? Okay. So any disturbing source, any disturbance in medium, in a medium, can generate a wave, right? Let's say if I'm speaking right now, let's say if you're sitting in a room, ठीक है, causes waves. Let's say if you're sitting in a room, ठीक है, I'm teaching you physics in a class physically, let's say, ठीक है, and you're standing over here, you're listening to me. So whenever I basically speak, I basically cause disturbance in air, air, right? And it basically reaches your eardrums, it makes your eardrums vibrate, that converts into electrical signals, and then you can hear me, right? What I'm saying, right? So this is just an idea of waves over here. So first of all, uh, let's talk about wave motion, right? So you have wave motion where you might have seen this in light also. Let's say if you talk about sun, right? The light reaching from sun to earth, right? Let's say this is earth over here. So light, again, light is a wave, it reaches back to earth over here. Okay, so since it has, the space has no vacuum, so we have a special type of wave which can travel through vacuum, that is called a transverse wave, right? So light wave is called a transverse wave. ठीक है, so we will study these type of waves in a while, right? Don't be scared. So okay, then we have some another sort of waves over here. Let's say if I have a spring, if I have a mass support system, and then if I have a, let's say, a mass here, if I push the mass in this direction, so it basically oscillates up and down, right? So it also produces some sort of a wave, right? That is called a longitudinal wave over here, right? Again, what are you doing? You're disturbing a medium, right? You're disturbing a medium over here, causing some motion. You are basically starting the motion that basically generates a repeating pattern that is called a wave, right? Okay, so several kinds of wave motion occur in physics, which we had just seen in the example. So we're really interested in mechanical waves, right? So mechanical waves basically are produced by disturbance. Mechanical means obviously you're doing some work, and that basically generates some phenomenon that is called a wave. Okay, if you see this example over here, we are basically causing a motion, right? We're pushing basically applying a force over here on the mass. It basically extends, and when we leave it, it basically causes vibration over here, right? So let's say if I'm speaking right now, over here, so what am I doing? Basically, I'm disturbing the air particles, and then it basically causes my this basically causes the air particles to vibrate, and it basically transmits my sound from one point to another point. Let's see, this is point A, this is point B, right? So again, this is an example of mechanical waves. So we are causing disturbance. Disturbance क्या होती है? कि we are basically causing the air particles to basically move in such a motion that it lets my voice to transmit from point A to point B, right? ठीक है? And how is the energy transferred? How is the wave transferred? It is transferred by basically medium, okay, that is vibrating about a fixed position. So what is the medium over here in this example? It's air, right? Air particle is a medium. Air has some particles which basically so it's acting as a medium. Medium क्या होता है? It's a wave which basically is causing the sound to travel from point A to point B, right? So air particles are vibrating left and right, okay, in this direction, which basically causes the transmission of sound from one point to another point. Then we have another type of wave that is called a progressive wave, okay, a traveling wave. So it's basically a disturbance which carries energy from one point to another point, right? So if I talk about seaside, okay, an ocean, or let's say a water body over here, let's say if it is transmitting some waves like this, okay. So let's say if you put a object here, right, it is going to travel with the wave and it's going to gradually enter here, right? So it has done what? It is basically transferring some sort of here, energy at point A, and after the motion, this energy is basically getting transferred here. So a wave that is moving, right? You can see the particles over here are basically moving across this, they're causing this box to vibrate and move here. So it's basically cause of sort of transferring energy from one point to another. So the major chunk, if you want to define waves simply, so we can define waves in two partitions. Okay, that is, it can be a transverse wave or it can be a longitudinal wave, right? So just to keep it simple, so we have learned कि mechanical waves क्या होती हैं, हमारे पास progressive waves क्या होती हैं, right? So mechanical waves के अंदर energy transfer नहीं होती है. In progressive wave, energy is getting transferred from one point to another, right? Over here. So now if I want to keep it generic and if I just want to define just a simple two types of waves, okay, that can incorporate every phenomenon which we have learned till now, that can be progressive also, can be mechanical also, but they all fall into categories. They can be either transverse or a longitudinal wave over here, right? So that is what we are going to learn in our world. Is it clear till now? If yes, thumbs up. Just an introduction about waves, both again. Okay, it's clear. Good. So now we have transfer wave over here. That is the most easiest to understand, I hope. So transfer wave, let me just map the transfer waves where you can find transfer wave in real life. Okay. You can find this in light waves, all the electromagnetic waves. Okay. All the electromagnetic waves, that is EM waves, which covers radio waves, gamma rays, X rays, ultrasonic waves. Okay. They fall into transfer waves. Okay. You can basically create this phenomena using this example also. Okay. If you have a rope with fixed end, right? So if you see the example over here, so this girl, let's say this girl name is, let's say Aisha, okay, I'm gonna call her A. So this is basically a fixed point here, and she has a rope over here, right? So what is she doing? She basically just causing the rope to basically go up and down, right? And you can see, okay, if you just do experiment in your homes, you would observe the same pattern here, right? So you would be basically experiencing a force, right? Because the wave will basically cause you to push in this direction, right? In the right direction over here. And you might see that there are some particles which are basically moving up and down, right? So it's a hump here. This part is called a hump because it is basically bended upwards, and this part is basically we are naming it hollow, okay, because it is downwards. Just to basically give you an idea, right? So what is this particular phenomena? The particles in this particular example, let's say this is particle P, it is just vibrating up and down, right? Vibrating up and down. However, the direction of wave, that how, where are the waves basically moving towards is this, right? So if you have this phenomena, if your direction of wave is in this direction, if your particle motion is basically in this direction, right? So you can just extend this, you can see that it is forming a 90-degree angle between each other, right? So this is the motion of the particles. So if you take any particle at any point, let's say this particular point, particle B, okay, again it is moving just up and down, right? If you just again find the angle, it will form this particular configuration over here, right? So what is a transfer wave? It is a wave in which the direction of disturbance, okay, that is the particle motion, is right angles to the direction of propagation of wave or the direction of wave, right? Right angles is very important over here, right? So if you want to define a transfer wave, if I ask a question, K, what is transfer wave? Just mention K for direction of motion is perpendicular to the direction of wave, then it's called a transverse wave. Okay? And again, this is how you can represent and test it out experimentally using a apparatus that can be found easily at your homes. Okay? Then we have longitudinal waves over here. And you can just create this phenomena pretty easily. Just take a spring. Okay? Let's take a spring over here and try to basically move it in this direction. Okay? Upwards, outwards, and inwards, right? You will eventually see that the spring has some regions which you can identify over here. The regions where the particles are pretty closer to each other, okay, and the regions, okay, where the particles, where the basically the neighboring spring sides are basically far away from each other, okay, which you can observe here. Okay, my color didn't change. You can observe here, right? So you can see that the wave motion is in this direction, which you can see, right? And the motion of the particles which you're causing it to move manually using a force is also in this direction. Okay, so you can see the direction of wave is in this direction, right? Okay, and the direction of particle motion is also in this direction, right? You can see that they both are parallel to each other, right? So they are both are parallel to each other. So how we can define a longitudinal wave? That is as follows. Okay, in a progressive longitudinal wave, progressive means energy getting transferred. The basically the medium, the particles are vibrating back and forth along the same line that is parallel to which the wave is traveling. Okay, it is not at right angles. You can see the angle between these two arrows is basically 0 degrees. So they are parallel to each other over here, right? So in a longitudinal wave, the particle motion and the wave energy motion is in the same direction, that is parallel to each other. And however, in transfer wave, it is perpendicular to each other, right? That is the differentiating point between these two. That's it, right? And where you can find it, you can find it in sound waves, right? Sound waves. You can find this in any spring motion, right? Any spring motion over here, right? So these are the practical applications of longitudinal waves over here, right? So yeah. So acha, now a longitudinal wave always consists of two parts: a compression and a rarefaction. Okay. Let me define this formally. Let me define this formally. The C are showing compressions and the R are showing rarefaction, right? So what is a rarefaction? First of all, let's see. As you can visualize from the diagram, so you can just relate this and write it down as follows. It is a region. It is a region where particles are closer to each other, and has high pressure, right? Because they're compressed together, right? They have red particle jumbled up together and then have high pressure, right? ठीक है जी? And you can see over here कि okay, sorry, the particle are far away. मैंने उल्टा लिख दिया. It should be far away. They are low pressure. You can see reflections here, right? The spacing between the two neighboring columns of springs are pretty far, right? As compared to compressions. ठीक है, यहाँ पे होगा basically are far away from each other. ठीक है, and they have low pressure. Right? You can see in rarefactions, the spacing between the neighboring spring coils are greater as compared to compressions. So they have also low pressure. You can compare these two parts. Right? Let's compare this with C. Now, if you want to just basically define what is a compression, it's just the opposite. ठीक है जी, it's just the opposite to what we have learned for rarefaction. ठीक है जी, so they're closer to each other. I should have changed just the term, not the entire thing. So they are closer to each other and they have high pressure, right? ठीक है, I hope it makes sense. ठीक है, this is just set. So the longitudinal wave always basically is produced from compression and set of reactions. ठीक है, that basically causes the energy to transfer, and you can see that the particle motion and the basically wave energy motion is parallel to each other over here. If it is clear, give me a thumbs up. Okay, it's clear to Vardha. I hope it is clear to everyone. Let's move on. Your question, you can raise your hand and stop me. ठीक है. Now, for simplicity, we basically use a displacement time graph, okay, to represent a wave. Okay. So we always represent a wave using a sine wave signal, right? We represent a wave using sine wave, so it's easier to understand here, right? And what is a sine wave? You might have learned this in maths, so just the right. Okay. So we have displacement against time graph. Displacement is basically if it is moving in the positive direction from the reference point or it is moving in the negative directions in the reference point, right? And this is the reference point here, the reference point. Acha, so what to note over here? What do we have here? We have some certain things which we want to basically understand in a way, right? So you can see that this is one complete wave, right? Right? And then after this, the wave pattern repeats, right? So we will learn कि ये होती क्या है, ठीक है? Where do we basically understand? Where do we stop? Where you realize one wave has ended and another wave has started. So we'll learn this in a while, right? So just important things to note here, just to basically understand the graph is as follows. You should know what is the wavelength of a wave, right? That is shown by lambda. You should learn what is this small a. You can see the graph is going up by positive a, okay, and it is going down by 8. Okay? A is the magnitude. It's a constant number here. Okay? Then you should know what is the crest, okay? What is the trough. Apart from this, you should also know that how much time it takes to basically complete one cycle, right? You should know what is the time period of the wave, right? The time period. And from this, you should also know that what is the frequency at which this wave is produced, because frequencies are very important over here. Right? Frequency describes what is the nature of the wave. Let's say if I talk about the electromagnetic spectrum, which we will learn in a while, inshallah, in the future, you will see that EM waves basically have a variety of frequencies, right? So it has a variety of frequencies. So upon frequency value, we identify कि ये let's say gamma ray है, ये X ray है, ये ultrasonic wave है, ठीक है, so on and so forth, right? So these are the quantities which you should know about a wave when you basically start to solve a question, right? अच्छा जी, so let's start learning these things step by step. Okay, Control C, I want to basically paste it into a blank slate. Okay, so from first of all, I'm gonna start with the idea of amplitude, right? Amplitude क्या होता है? Amplitude. So first of all, let's define formally. What is it? It is the maximum. It is the maximum displacement from the mean position. Mean position, right? So we are calling this as mean position, right? This center point, this line which is crossing across the graph. This is the mean position, right? Which is lying at zero. Okay, this value has zero. Okay, this is the mean position. We basically want to define this as follows. Okay, if you have a graph like this, right? Let's say this is time in seconds, and this is displacement in meters. Okay, and we have defined this center line as the mean position. Okay, this graph is oscillating. This graph is basically moving up and down across based upon this green line. So it is basically fixed at 0 meters, right? So by how much it basically goes up, okay, or down, because sine का graph is symmetric, it is same as basically the positive and negative side amplitude, right? This is basically called the amplitude A. Let's say if this position is basically 2, and if this position is also basically -2, the amplitude of this wave is basically 2 meters. It means that the wave is oscillating, it's moving. Okay? This is amplitude. Then we basically want to learn what is a wavelength, right? What is the wavelength? And wavelength is basically, again, it is basically it has a symbol called lambda, and it is measured in meters. Amplitude is also basically measured in meters, right? And this symbol means lambda. Okay, so what is the wavelength? It is just the length. It is the length. It is the length of one complete cycle, right? What is, you might have a good question. So let's first of all start on that. Let's say you have a wave which is basically moving like this. Okay, again you have time in seconds, you have displacement in meters. Okay, so you might observe this, right? So you have some points here, right? You have a crest, okay, and then you have a trough. So what is a crest over here? Crest is basically the position where you have maximum positive amplitude, right? And what is negative amplitude? Okay. So similarly, EB crest होगा C and EB trough होगा, right? T. So how can you measure one lambda? One lambda can be between from one crest to crest, right? Or can be from one trough to another trough, right? Or you can also basically find a pattern here, right? If you are smart enough, you can see कि sir, you can say कि sir, ये देखें ये wave एक start हुई and then ये यहाँ पे complete हो गई. Then this wave is getting started again from here. So it is basically repeating it over here, right? So you can say कि sir point A से point C तक, let's say point D तक one complete cycle पूरी हो चुकी है. So this can also be called as one lambda, right? So one complete cycle is basically duration after which the wave pattern starts to repeat. Or if you remember crest, what is a crest? So from two neighboring crest to crest, you also have lambda. And if you know what is trough, so you can just say, okay, sir, the corresponding to trough distance is also called a wavelength, right? So this is the two quantities which have been introduced to you. If it makes sense till now, thumbs up. Quickly, I want to move on. आगे Okay. It makes sense. That's good. That's good. Right? Now you know okay, the important parts of the wave. Okay, that is amplitude क्या होता है, what is the wavelength. You know also what is one cycle, right? And how do we basically measure one cycle? Can we measure from the starting position, or basically if you know okay, sir, one cycle started from here and then starts to repeat from that point A to D. So this is also called one cycle, right? Or from two consecutive crests, it gives you one cycle. Or from two consecutive troughs, it gives you one cycle, right? Now we have another thing at our end. Okay, what is a time period, right? What is time period? What is time period? Right? It is measured in seconds. It's just time, right? So let's say if you have one wave like this, right? This is one complete cycle from here till here. Okay, and you can see sir, this is also one lambda complete cycle. So what is time period? It is the amount of time. It is the amount of time to complete, or not time. It is the amount of duration to complete one cycle, right? Then from this you have frequency. right? Frequency is measured in hertz. And what is frequency? It is pretty simple. It is a number of cycles in 1 second, right? And how do you relate for frequency? How do you find it out? First of all, you have to find out time period. Then you can simply find out the frequency by using the formula. That frequency is 1 upon time period, right? It basically says ki, how many cycles are getting covered in basically a time period t, right? So yeah, so this is basically going to give you answer in hertz. Okay. Okay. So these are the four things which you should know about the structure of wave and some properties of wave, right? So again, these are defined over here that you can basically refer to as formal definitions. So it is just what we have discussed till now, right? Achari. Then we have a discussion on phase. It's not so important for your chapter for your content, but just to have an idea over here, right? So you can see that the arrows here, right? The arrow A, the arrow C, okay, and then you can also see arrow B and arrow D, right? So the short arrows A, B, C, D basically show the direction of vibration of the particles at position A, at position B, at position C, and at position D, right? So you can see that A and C are basically moving in the same direction, and the arrow also has the same length. So these A and C basically are in phase. In phase means के they are moving in synchronized motion. ठीक है? अगर A नीचे जा रहा है तो C भी नीचे जाएगा, and if A is moving up, C is also going to move up, right? So they are synchronized. So they are called in phase. That's the important part which you want to learn. Okay, they're called in phase, right? Similarly, you can see that B and D are basically moving in a synchronized way. They're also basically in phase to each other, right? However, if you compare A and D, they are moving opposite to each other, so they are called out of phase. That's it. That's what you want to know about phase over here, right? So if they're moving in the same direction as compared to time, let's say A is moving down, so C is also moving down. If A is moving upwards, so C is also moving upwards, okay, at the same time. So that means that they are in phase, they're synchronized to each other, so they're called in phase. Okay. So if they're moving in the same direction at a particular time, they're in phase. If they're moving opposite to each other at a certain time, that are called out of phase to each other, right? Okay. If it makes sense, thumbs up. Okay, it makes sense to me. But that's good, right? That's good. अच्छा जी, सो अब आपने बोला सर हमने इतनी थ्योरी पढ़ ली, तो अब कुछ न्यूमेरिकल करवा दो सर, बोर हो गए हम लोग, राइट? सो या ओके, लेट्स कम टू दैट. सो you know what is frequency of a wave. You just learned कि sir it's the number of vibrations in 1 second. You know what is lambda. Lambda is just the length of one complete cycle. But if you want to find the speed, कि sir speed, let's say a particle जो वेव के अंदर जो मोशन हो रहा है एनर्जी का, वो कितनी स्पीड पे हो रहा है, सो यू कैन बेसिकली फाइंड दैट थिंग आउट using this equation, that is speed equals to f lambda. ठीक है, lambda f. ठीक है, where basically lambda is what? Lambda is your wavelength that is found in meters, and f is your frequency that is found in hertz, and b is your speed of wave that is measured in meter per second, right? अच्छा जी, अब आप सोच रहे होंगे सर ये फॉर्मूला आया कैसे? That's again a good question, right? If you recall your kinematics का chapter, so you what is the formula of speed? It is the rate of change of distance, right? Right? तो यहाँ पे if I just want to find for one complete cycle, so how much distance a particle is traveling in one cycle, that is lambda, right? And what is t? The t is basically 1 upon t, right? If we replace this formula over here, let's see what do we get. We get speed equals to lambda times 1 upon t. This entire factor is basically frequency f. Therefore, you have speed equals to lambda f, right? That's how the formula comes, and that's how you basically make sure that the SI unit for speed again remains meter per second, right? Okay, this is just an experiment just to show over here. At 0 seconds, you can see the wave is basically starting from a crest, right? And this crest A after 1 second is basically here, right? So how many waves it has traveled? It has traveled 1 lambda. This is 1 lambda. This is 2 lambda. Okay, this is another lambda. The entire distance, total distance which the wave has traveled in 1 second is 3 lambda, right? So this is saying कि हमारे पास vibrator है which is basically moving the waves at a frequency of 3 hertz, right? And it should make sense. ठीक है? So 3 hertz means कि if I have a frequency of 3 hertz, let's say if C equals to lambda f, okay, and I can also basically I have a frequency, I have the basically. अच्छा जी, so now I was just saying here it is moving with the frequency of 3 hertz, right? And after 1 second, it basically covers a distance of 3 lambda, right? So let's find it out. Is it correct? Does it make sense? Okay, if it is having a frequency of 3 hertz, So after 1 second, it will cover the distance of 3 lambda. Does it make sense? So let's formulate this. So what is frequency? Frequency is 1 upon t. Let's place this in the formula. What do we get? We get speed equals to lambda upon t, right? So if I try to relate a lambda and time period, that is going to be a direct proportion, right? Okay, over here. So what do you see over here? What is happening? So it is basically saying, let me just keep it more simple ताकि आपको समझ आ जाए. Let me not go to equations. I was confused over here. So what is frequency, by the way? Frequency is basically how many, it basically the time period to complete one cycle, right? So how many cycles are completed in one time period, right? If you have frequency of 3 hertz, okay, that means that you have a time period of what? 1 upon 3 seconds, right? Okay. Does that make sense? Does this make sense? This part? कैसे निकाला ये? Just put the formula value here, right? So 1 upon 3. So that means कि if I basically have a time period of 1 second, that means कि I can have 3 cycles over here, right? तो ये cycle basically 1/3 second के लिए आया. ये cycle basically आया आपके पास 1/3 second के लिए. And the remaining cycle for 1/3 second. If you add 1/3 plus 1/3 plus 1/3, that gives you 1, right? That is why you have 3 cycles. That is 3 wavelengths in a time period of 1 second, right? So this is how you relate time and frequency. And you have a relation for frequency and time that is inversely proportional to each other, right? So frequency, if you have high frequency, you will have a smaller time period, right? So that's how you can relate this. So keeping this in mind, quickly solve this question and give me an answer. Okay, you have this formula that speed equals to lambda f. You have 1 minute to solve it out. You want to measure lambda. Okay, you can place your answer in centimeters. No worries. You have a minute to solve it out. If you're done, raise your hand. Okay. Okay, G, let's solve it out now. It's pretty simple. You guys are taking so much time. So what do you have here? You have given some values here. So you have a speed over here that is 4 centimeter per second. Okay. And you have a frequency here that is of 2 hertz. You want to find out basically lambda. It's straightforward. Just apply the equation speed equals to lambda f. That gives you 1 mark. And just make lambda subject. So your lambda is basically 1.2. That is going to give you a wavelength of 2 centimeters. Okay. That is the answer. It's pretty straightforward. Just an application of the formula which you have learned, right? अच्छा, मुझे बताएं जल्दी से, व्हेन आर यू अवेलेबल टुमारो? आई वांट टू हैव एन एक्स्ट्रा क्लास, बस कल ये क्लास कैंसिल हो गई है, सो आई विल हैव एन एक्स्ट्रा स्लॉट, सो आई एम थिंकिंग टू गिव इट टू यू गाइस. आई एम थिंकिंग अबाउट, लेट मी थिंक. क्लास मेरी कैंसिल हुई है एएसटी. तो आर यू अवेलेबल एट 8 p.m. PST tomorrow for the extra class?
Yes, sir.
ठीक है, सो आई एम जस्ट अनाउंसिंग इट इन द ग्रुप ताकि अब थोड़ा हम लोग स्पीड अप करेंगे, ठीक है? ओके, सो लेट मी जस्ट अनाउंस इट, ठीक है? Extra class announcement. So who got this exact answers? Raise your hand. Okay. See, Hamza से हुआ था. Not difficult. Okay, that's good. 8 p.m. PST. अच्छा जी. So let's quickly move on. I have another class. I would have to just summarize. Wave fronts and rays. ठीक है. Just to give you a starting point of view कि हम क्या बात करेंगे इसके अंदर. That is, just imagine a wave in a let's say in a aquarium, right? You might have seen aquarium, right? जिसके अंदर फिश वगैरह रखते हैं हम लोग. Let's say you have an aquarium here like this. ठीक है. You have an aquarium. It's filled with water. आपने एक फिक्स करा है ऑसिलेटर, राइट? यू हैव फिक्स्ड वन vibrating source. Vibrating source. It's basically causing the motion to be like this, up and down, right? So you're seeing water waves like this, right? So if I fix my eye from the top, okay, I will see a pattern like this. If you just stay with me for a while, if I see the top view, जहाँ से मेरी eye placed हुई है, that is going to be as follows. You will see lines which are crossing, right? These are basically called crests. This will be called troughs. Okay, you will not be able to see complete waves passing out if you're seeing from the top, right? So you will basically see sort of lines, right? Let's say if you have multiple waves like this, आपके पास एक वेव ये है, एक वेव ये है, आपके पास एक वेव ये है, right? So you can see that these are called crests, right? They're called crests, sorry, and these are troughs, right? So if you basically join a line from crests, all crests, right, and all troughs, okay, so these are called wavefronts, right? You might have observed this in aquarium. Who has observed this? Has anyone seen this? This is true. Yeah. If you observe the aquarium from the top, you would see these. You will not be able to see कि wave ऐसे जा रही है. वो आपको यहाँ से दिखेगी. If you see from here, right? From top, you will see just lines passing through, which are moving in this direction, right? So these are basically very simple to represent in a wave. And might have heard कि light की जो properties होती हैं, reflection, diffraction. This is also true for water waves, right? Because we will represent our water waves using wavefronts, and all of the properties which have reflection, we have reflection and we have diffraction. ठीक है, that are basically going to represent it using these wavefronts. If you see the experiment, ठीक है, so आपको क्या दिख रहा है इसमें? ठीक है, you're not able to see any wave pattern here, right? Instead you are seeing some dark shallow regions. So you can just call this particular part as, ठीक है, wave. ठीक है, you just show it like this. ठीक है, कि आपकी wave is basically coming in this direction. ठीक है, and it is now in this basically in this shape, right? These are all wavefronts. ठीक है, so you basically use wavefront idea basically to describe any phenomena that is reflection or diffraction using wavefronts, right? And then we have ray. So what is a ray, by the way? If you want to basically highlight a line that is drawn right angles to wavefronts which shows the direction of travel is called a ray. ठीक है, let's say मैंने इस डायरेक्शन को जो मैंने बनाया है, this particular arrow which is showing the direction of motion of the wavefronts, this particular thing is called a ray. That's how we basically represent. So why do we need to have an ray? Because if you recall your classes that was in light chapter, right? You basically draw normal here, right? Normal is basically a line which is perpendicular to the surface, right? And am I playing with the screen? I can see that. Actually, so what do you do? You basically, mama, what are you doing for it? क्या कर रही हैं आप? You're trying to draw something? Okay, please erase that. Actually, so if we assume here, if we have a light ray over here, right? So basically, let's say if your light ray is hitting here, right? Then it goes back here, right? So the angle of incidence is the angle of the incident ray, right? And the angle of reflection is the angle of reflected ray, right? So this is called E, reflected ray, and this is called your incident ray. right? So if you recall your light chapter, basically what was the rule? That angle of incidence is equals to angle of reflection over here, right? So that exactly applies to waves, right? And let me first of all delete these annotations. Okay, delete, clear all drawings, and let me basically. Okay, so I'm going to basically limit something over here. Cross, we'll go to settings. Hmm. Okay, so guys, please don't do that. Okay, so we are already speeding up. I don't want someone to play on the screen. Acha, चलें, understandable. Okay. So what basically are we showing over here? Let's say we have a wave which is coming over here, it hits a particular point on the surface, okay, and then this wave basically reflects back, right? And surprisingly, and it is very interesting, that angle of incidence which it basically makes with the normal is same as angle of reflection over here, right? So the property of light, ये reflection होता है हमारे पास, it applies here also, right? That in reflection of waves over smooth surface ensures that the angle of incidence is same as angle of reflection, right? So this is an interesting property which basically is applied to the waves also. Okay, and let's move on. This is just stating over here okay, what have we discussed till now. The ray are at they are at right angles to the direction of travel, so they are called rays. Okay, so this is basically a ray. Wave front से angle जो बन रहा है ray का that is perpendicular. So basically we are showing a ray over here, right? That is incident ray. Then we have a reflected ray over here. And the angle of incidence they're saying okay, in the experiment is 60 degrees, right? So if we have a smooth surface here, right, that is not rugged or has rough edges, so it's going to basically ensure that angle of incidence is same as angle of reflection. So this is also going to come out to be 60 degrees, right? So incident angles at other angles show that the angle of incidence and the angle of reflection are always equal, right? So this is how reflection occurs. So you might be asked to draw diagrams in your exams. कि आपके पास they might ask you draw a reflection of wave scenario. So you have to make sure that you have wave fronts and you have rays which are perpendicular to the incident ray, right? And you also have to you should have a normal also in your diagram. Okay, and everything which is displayed over here, right? And you would have to make sure that the angles are approximately same, right? So since you're doing randomly, okay, so it may just make sure that it is pretty close enough to each other. You might use a protector if you want to, but if they say just sketch, so it can be a rough sketch, right? Actually, now we have refraction over here. Can anyone explain and let's say your ideas about refraction? What is a refraction according to you? What do you know about refraction?
Sir,
Anyone?
refraction is the bending of light from when it goes from one medium to another.
Okay, Zabardast. That's good. Perfect. Right. So what is refraction is basically if you talk about light waves. So let's say if I have a glass here, right? And let's say the light ray is coming from here, it hits this surface, right? It hits the surface over here. So since it is the light ray is flowing through air here, when it enters the glass, it basically should bend inside the glass, right? Because the medium glass has different diffracting index and air has a different diffracting index, right? So the change of medium hota hai. So the light ray, basically the wave basically bends, right? And it depends upon the density of the material, right? If it is going from low dense to high dense, it bends towards normal, right? If it goes from high dense to low dense, it basically bends away from the normal. So अगर मैं आपको दिखाऊं ये lecture session, let's say you have glass, you might have done, you do this in your shadow of light. This is glass, this is air here, right? Let's say the light ray, this is normal here, and the light ray basically enters here, right? So it's going to bend towards the normal. Okay, let me just draw glass outside. ये क्लास को बाहर कर देता हूँ ताकि I can draw the light rays easily. This is the glass here, and if I draw the wave, it bends towards the normal. ठीक है, my it is pretty bad. It bends towards the normal. Right? Let me just make sure here. And then as soon as it basically exits, it should bend away, right? So this is normal here, right? This is normal n. This is normal n. So this is the angle of incidence, and this is the angle of refraction, right? So this is what happens over here because glass की density अलग है, A की density अलग है, right? So this bending occurs in that is in light, right? Now we're talking about scenarios of waves. So can anyone explain कि refraction in waves कैसे होता है? How can you relate the idea of light just which you have just seen? How is it applicable in waves? Anyone? Give me a guess. And we're not judging you guys.
Sir, it goes from like I guess shallow to deep water or deep to shallow water.
So let's say shallow to deep, will it basically the wave fronts would bend away from normal or towards the normal? If I'm going from shallow to deep waters.
Sir, it would bend towards the normal maybe.
Okay, ठीक है, that's close. ठीक है. So let's first of all read the content and let's basically analyze this first of all. So let's say you have a water tank here, which you can see, and then if we are basically placing a glass plate here, right? So हमारे पास glass की plate है, पतली सी, ठीक है, sort of a this sort of plate here, right? We're placing this glass plate inside the water, right? So we're basically water is over the glass plate, right? We're basically dipping it inside the water so that the water comes over the glass plate, and we can see some phenomena here, right? It's about 1 millimeter deep and 5 millimeter deep elsewhere, right? So yeah. And continuous state waves in the shallow regions are found to have a shorter wavelength than those in the deeper, right? The wavefronts are closer to each other, right? So if you see figure 3.18 closely, if I can zoom in, yeah. So what do you see here? हमारे पास glass plate है, which is basically 1 millimeter deep from this center, right? यहाँ से यहाँ तक ये basically it is 5 millimeter deep. It's sort of a triangular prism, right? ऐसे हमारे पास this is the sort of a plate which I placed, ठीक है? This is the plate which I placed inside the water, right? So from this basically the bottom part is 5 millimeter deep, right? And the thickness of this basically rod from here till here is basically 1 meter, right? So what is happening here? If you see closely, this particular part, this center part, जहाँ से बहुत basically shallow part में deep में part में जा रहा है ये. So what is happening here? If you compare the wave fronts क्या है हमारे पास? What are the wave fronts here? This is a wave front, right? So what हमारे पास basically आ रहा है from the top. And if you see from here, the wave fronts are pretty close to each other, right? The wave fronts are pretty close to each other. You can see. If I can delete this highlighted part, we'll be able to see that. Okay. So you can see कि यहाँ से बहुत deep है, and then it basically is getting shallower, right? So we can see that where the depth is pretty deep over here. So you can see something over here, which is written over here. Let me zoom it out, that you guys can see. Zoom out from here. They're saying कि Uh, where the shallow region are found, they have a shorter wavelength over here than those in deeper. ठीक है. So wavefronts are closer to each other over here. So both sets of waves have frequency of the vibrating bar. Since speed equals to lambda f, it has lambda degrees. So speed is basically going to basically vary. So but f is fixed over here, right? So we have this scenario over here that speed equals to lambda f, which we have learned in the last lecture, right? So what is happening? हमारे पास speed is constant, right? Because we have a vibrator here. Let's say we have a vibrator here, which is basically producing the waves, right? The vibrate कर रहा है basically in this direction, right? It's producing the ripples, right? Then it is basically saying कि since the vibrator is basically working at a fixed frequency, तो वो क्या रहा है? हमारे पास frequency is fixed, right? Frequency is fixed. So what two things are varying over here? The two things which is varying over here is the speed and the lambda, right? So if I make f subject, so f is going to be speed upon lambda. right? So you can see that in shallow regions, the lambda is greater, right? So the speed should decrease. ठीक है? Should it decrease or increase? If I basically am entering from deeper to shallow region, if my f is constant, it is fixed. I want to basically make sure कि हमारे पास frequency constant है. So to basically compensate, if my lambda is increasing, should my speed increase or decrease? Yes. Anyone? Let's say my path frequency is this. I want to make sure that my frequency is 4 hertz, right? My initial lambda that is in deeper region is 2 meters, right? So if I want to find out the speed, my speed would be what? Lambda f. So I will multiply it out. So I get 8 meter per second, right? Now I'm doing what? My frequency is fixed. मैंने कर दिया lambda मेरी कम हो गई, right? Now it is 1 meters. Lambda bar. I want to find lambda bar. I know that my frequency is fixed, right? My frequency is fixed. I cannot change this. So if I find out the speed, कैसे निकालूंगा? The speed bar, the speed bar is going to be basically lambda bar upon frequency bar, right? तो frequency हमारे पास fix है because हमारा vibrator जो vibrate कर रहा है fix frequency पे कर रहा है, ठीक है? So the V bar is going to come out to be what? 1 upon what is the frequency for? So what is happening to the speed? It has become 0.25 meter per second, right? So in shallower region where we basically have wavefronts closer to each other, my speed increases or decreases? Does it increases or decreases? What was the speed before? It was 8 meter per second, right? So हमारे पास lambda was 2 meters. Now when my speed is lambda, my wavefront, the wave basically wavelength is 1 meters. Now
So it
speed is,
would decrease.
yeah, ठीक है. So you can see that in shallower region, if the wave is basically, yeah, decreases. If the wave is coming from deeper to shallow region, the speed is going to decrease, and the wavelength, basically is also going to decrease, right? Because if you recall, what is the wavefront? ठीक है, what is the wavefront? ठीक है. So wavefront क्या हमारे पास is joining all to crest over here, right? So let's say if I have another wavefront here, जो हमारे सारे crest को मिला रही है. So this distance between the two blue lines is going to give me a lambda, right? Because if you recall your last lecture, so this is a crest and this is a crest. So the distance between the two crests is also a wavelength, right? So if you want to find a wavelength from wavefronts, that is simply the distance between two wavefronts. ये हमारे पास lambda है. This is lambda, right? So you can observe over here if the wave is coming towards the shallow region, ठीक है? So the wavefront is decreasing over here, right? And then the speed also decreases. So this is the deeper region over here, right? And this is basically a shallow region over here. So if the wave comes from deeper to shallow region, what happens? The speed decreases and the wave length between the two consecutive wavefront also decreases over here, right? If it is going from shallow to deep region, ठीक है? So it will be opposite over here. Speed is going to increase also, and the lambda, the wavelength between the two consecutive wavefront is also going to increase. Okay. So this is how refraction takes place in the waves over here. So if it is clear, give me a thumbs up. It's simple. I just I want to basically now observe this using wavefront ideas again. I hope the numerical make sense. Okay. So numerical value set is making more sense. Okay. Okay. That's good. So again, we have another scenario over here. यहाँ पे हमने sort of trapezoid class रखा है, ठीक है? So what is happening over here? You can see that okay, when the plate is at an angle to the waves, ठीक है? The direction of travel in the shallow region is bent towards the normal, right? That's what we have discussed here. मैं आपको पूछा था कि let's say I guess I asked further if it goes from deeper to shallow region, ठीक है? Let's say this is the shallow region over here. ठीक है, and this is the deeper region over here. Let me just mark this out. So let's say this is the normal, right? The red one is the normal here. So आपके पास जो wave fronts आ रही हैं, right? Let me first of all draw the ray. Let's say the waves are hitting like this. The waves are hitting like this. It's going to bend in this direction, right? Clearly. So if I want to draw the wave fronts, वो हमारे पास बनेगी ऐसे, right? So you can see the normal, it is basically bending towards the normal over here, right? This is the normal here. So obviously, when it enters from deeper to shallow region, it basically occurs why because there's a change of speed, okay, and also there's basically a change of wavelength, which you just see over here, right? So if it enters from deeper to shallow region, the speed decreases, and also the wavelength, that is the distance between two consecutive wave fronts, also decreases over here, right? So that causes a change of direction also, right? So if you can see this diagram, ठीक है, यहाँ पे जो वेव enters हो रही हैं at a particular angle, you can see that they are bending towards normal, right? If you just see it over here, ठीक है? So if I draw normal here, if I draw normals here, this is a normal, right? This is a normal, this is a normal, and this is a normal here, right? So you can see that this wave front, right, is bending. It has a sort of this direction here, right? ठीक है? In this particular diagram, let me choose another color. This is sort of this, right? ठीक है जी? So you can see this particular direction over here. This particular wave is basically bending in this direction, right? Right? If you want to just draw a ray over here, so it's bending towards the normal, right? Does that make sense? If yes, thumbs up. This that's simple, right? So it's not so complicated. कोई numerical equation वाला इस्तेमाल नहीं होंगे. Just have to basically learn how to draw wave fronts and just normal and just create a reflection scenario over here, right? This is a better representation of the scenario just to basically make you guys understand, right? So what is happening here? So in deep water, basically they're moving faster, right? So this is a wave front which is being shown over here. A wave front one, wave front two, wave front three, and this is the ray which is drawn here, right? Okay, this is the incident ray. If I just want to label it, this is the incident ray. I hope it will make sense after this. Okay, and this is the normal here, right? Now हमारे पास ये normal है. This is the normal here, the dotted black line. And you can see here after entering the shallow region, the wave fronts basically have bent towards the normal, right? And if you basically just confirm this from the refracted ray, you can see that the refracted ray basically has bent towards the normal, right? And you have now two angles over here. That is angle of incidence. And then you have angle of refraction, right? It's not reflection, it's refraction. You don't be confused in that. Okay? So this is how you basically show it, and they are already basically saying it to you. Okay, in shallow water they move slower, in deeper water they basically move faster, right? So that's how you will be drawing diagram in your exams, and you will be given topical past papers, so where you basically can get in touch with the actual question which are getting tested in your exams. Okay, I guess this now makes more sense, right? Just give me a thumbs up if refraction is clear. Then we move on towards the last topic, that is diffraction. Okay, makes sense to Mama Hamza. Maeve, is this clear? Are you here? This refraction, I guess you joined during refraction. You can watch the starting of the class through recordings taken. Is this clear, Maeve? Okay, I guess Maeve is having some internet issues. She is connecting. Connect. Okay. So let's move on. Then we have diffraction, right? So, whatever you're learning right now, you simply apply this from your chapter of light, right? So that's how we have combined the light and the waves together into a single field, right? But their properties are pretty similar. The phenomena are pretty much similar, right? And it is practically experimentally proven also, and also numerically also. Okay. So if you want to prove some phenomena, उसको आप first of all you want to prove it using mathematics, and then you want to prove it experimentally, right? And if both of the experiments are done, that basically finalizes the formulation of entire new phenomena, right? Let's say if I say कि मेरे पीछे window के ऊपर there is a black hole which can take me to another universe, people will say I'm mad, right? So, but if I have the mathematics and if I have shown them actually, okay, if I have basically evidence, okay, I took 3% with me and I basically came back also, right? Then that would be basically authentic and that would basically stand the scientific testing method, right? So that's how you basically come out for discovering any new phenomena. So now coming back to diffraction, if anyone knows anything about diffraction, please share your ideas here. What is diffraction? Yes, participate, please. This class is supposed to be full of participation, right? Mashal, can you speak up? Hello, Mashal. Are you here? Is Mashal here, or is Mashal just having a cup of coffee and
Sir,
just
can I say?
yeah, sure, Vardha. Start.
Sir, diffraction is the bending of waves when they pass through like a narrow gap or a narrow area.
Okay. Is it the bending or the spreading?
It's the bending, like वो bend हो जाती हैं.
Okay, good. Okay, I have a comment here from, I guess, I believe it is Mashal. Yes, sir, I am here, but haven't learned this. अच्छा, ठीक है. So, just imagine कि you have a small space in it. Do I have something to show over here? Uh, I have something here. I have a eraser and a sharpener, right? So let's say this is a sort of a blockage, okay? And then if I basically allow a small gap between this, and if I pass a light ray from here, right? Let's say from this side. So if you see from the other side, you will see that the light has basically spread around like this, okay? You might also note this, okay, if you use a flashlight, okay, and just close your door and just open the door by small distance, just flash your flashlight from the other side. You will see from the other side, the light is sort of spreading in this area. That is sort of diffraction, right? So when a ray that passes through a small opening, okay, that is very small as compared to its wavelength, it basically spreads, right? That is called diffraction, right? Similarly, in waves, it is getting applied and it is proven that it can also happen in waves over here, right? That is again interesting, right? So let's see the figure 3.1.10a. Okay, so what is happening here? It's pretty interesting, right? So you can see here, this is a small narrow opening over here. This is a sort of a wide opening here, right? So the opening of the spacing matters over here. Okay, the smaller the opening, the greater the diffraction over here, and the lesser the opening, and the basically lesser the diffraction over here. This is the relation between the spacing and the bending of the wave. Okay. So again, what do we have here? If you just see, let me just use a red one for the input. So these are waves which are coming from the source side. Let me just draw this. These are waves coming from the source side. So this is a small opening over here. This is basically a spacing of d. Let's say हमारे पास the wavelength of the wave which is coming from the input from the left side is basically, let's say, 4 meters. So my d should be pretty smaller than this. It should be around 1 meters. Be pretty small, right? So this is not the ideal scenario, but just to make you guys understand, okay, the spacing should be that much smaller as compared to the wavelength of the input coming wave, okay, that is hitting the spacing, right? If this is true, then you can see this sort of beautiful spreading of the wave. I'm going to draw this using my special bronze color, right? You can see the waves basically then diffract in this direction. Okay, that's pretty bad. That's pretty bad. That's again bad. Right? So you can see that this sort of spreading of the wave is called diffraction, right? So as soon as the wave hits the small opening, it basically starts to diffract. Okay, and you can see they're sort of concentric semicircles, right? Almost semicircles, right? So the smaller the opening, the greater the bending of the waves. Okay, that is going to pass through the small slit or opening over here, right? This sort of semicircle concentric patterns here, right? So if I want to describe this formally, that is going to be as follows. That is, it is the spreading of the wave, okay, after passing through a small opening, okay, or a small slit over here, right? So again, this is saying a stray water waves enter the particular uh, hole, okay, and then it basically, the cap is narrow and you can see the wavefronts curve around the edges that basically sort of produce a circular wavefront over here, right? So the straight wavefronts, if I can just draw this, this should be straight over here. So the straight wavefront basically are hitting this particular slit and basically comes and curves back to concentric circular wavefronts. Okay, that's how deflection takes place. Okay, and it is also true in if I want to draw rays. Okay, want to draw rays over here. ठीक है तो कैसे बनेगी तो the rays for the input is going to be like this. The ray of input is this, right? It's going to be the center of the wavefront and is perpendicular, ठीक है, to the wavefronts. And for the output, the wavefront are going to be like this, ठीक है. You can see a perpendicular ray, ठीक है. Because since they are circular, I have to draw many rays over here, right? So you can see they already they are spreading around, right? It is perpendicular to the rays. Okay, so these are the rays which is basically getting diffracted over here, right? So we have basically done what we have spread the wave around this particular opening over here, and this therefore is called diffraction of waves over here, right? And if it makes sense, give me a thumbs up. I hope it was not so difficult to understand it. So I guess it is clear to Mama, Mashal. What about Varda and Hamza and Meave? Okay, it's clear to me also. That's good. Okay, I'm going to move on. If you have questions, stop me. Okay. And then similarly, if you just check it out for a wide opening, okay. So again, you have a straight sort of set of wavefronts entering, and you can see here there is very small sort of bending of the output wavefronts on the right hand side. That is in the blue color. You can see there almost three wavefronts. You can see three rays over here, right? That is dictating that there is not enough bending over here. They are getting sort of bended, but not to an extent like this over here, right? So this is how the spacing can affect the deflection rate over here, right? So these are used basically in practical scenarios. If you know basically what is a harbor is the region basically where you have ships, right? So they also basically specify the area कि कहाँ से ships enter होगी हमारे पास dockyard में park होनी है और place होनी है. So they basically want to also build some boundaries, right? So since they have also made boundaries and they have small opening for the ships to enter. So obviously this is a small opening here. This would also cause diffraction behavior here. Okay, if so the opening is pretty small, this would basically cause huge concentric ripples. Okay, and this can basically lead to some huge waveforms. Okay, that is going to crash along the seashore here, right? So they are also basically taking care of this spacing over here, right? इसका formula होता है पूरा that is not going to be used for O levels, but you have formulas for. Actually, so now I just want someone to basically let me just finish it out. I would basically request someone to give me a quick recap of what we have done till now, so that the ones who missed the last lecture can also get in. Okay. So we have just the last thing to cover here. That is, what is the effect of wavelength and gap size on diffraction, right? Let's say I have this, right? This is basically, this small d is basically what? This is the diffraction gap, right? And the lambda is basically the wavelength, right? Wavelength क्या है basically जो हमारे पास wave produce हुई है, right? जो pass हो रही है, जो hit कर रही है on this side, and then after it basically sort of diffracts, उसमें spacing में wavefronts के बीच में क्या फर्क आएगा? So that it is going to change the wavelength of my the wave, right? And what is the relation between that? So I would request if someone sees the experiment here, what do you observe? If I decrease the spacing between the opening, is it increasing my wavelength or decreasing my wavelength? Yes, anyone? तो कम आ रहे हैं? नो वरीज. इंक्रीज और डिक्रीज. If you say कि सर वेवलेंथ इंक्रीज हो रही है, give me a raise of hands. Okay, wavelength is increasing. Okay, I'm sure says कि wavelength is increasing. ठीक है. Okay, so let's see what is happening here, right? So let's go back to the slide and let's see what is happening. In figure 3.1.10a, that is the one which has small opening. So the gap width is about the same as with the wavelength of the wave. So they are basically stating कि जब हमने experiment setup किया था, तो उसके अंदर जो हमने wavelength produce की थी, that has the wavelength of 1 centimeter. So the distance of separation which they have used is also 1 centimeter. So it's pretty close to the wavelength also. ठीक है. So in my slide, basically I gave you an example, कि 4 meter, 1 meter of, right? So you can see that it passes through this particular separation gap and becomes circular and spread out in all directions, right? So if they figure in 3.1.10b, that is the one which has greater spacing over here, which is this. So the gap width is 10 centimeter, that is 10 times the wavelength. Okay, let's say if I take you over here, this basically separation, this d is 10 centimeter. The wavelength of this wave which is hitting this separation is only 1 centimeter, right? So you can see there's almost no diffraction over here, right? So that is the relation between the wavelength and the gap separation over here, right? And the question that is basically I wanted to ask, okay, is the wavelength changing if it passes through this particular setup or not, right? So would it affect the wavelength? Would the separation is causing an effect on wavelength? If I erase this, then let me erase this. Let me erase all of this. If you now observe this, okay, just observe the dark patterns, the dark parts, that is the troughs. Okay, so we can also create wave fronts using troughs. Okay, so is it causing a change in the wavelength? Let's compare one dark to another dark point. Okay, let me just draw it here. So this is one trough key wavefront. Okay, this is another wavefront of troughs. So this is entering like this, okay? And this is the wavelength that is entering this particular separation here, right? Let me draw from red the sort of the affected one. This is this, and this is this here, right? This is the lambda that is basically on the right hand side. Is it varying? Is it varying? Yes, is it varying or not? If you say कि sir wavelength is getting varied, give me a thumbs up. If you say कि wavelength is remaining the same, give me a thumbs up. Okay, you all say कि it's not varying. ठीक है, that is the correct answer, right? So wavelength does not vary. ठीक है, diffraction में is just the spreading of the wave, same wave. ठीक है, it's hitting this particular setup over here, right? Wavelength remains same. That was the thing which I wanted to ask. ठीक है, wavelength change कब होती है? जब रिफ्रैक्शन होता है हमारे पास. ठीक है, so wavelength only changes in refraction, right? That is the most important part which I wanted to highlight here, right? So this is some basically misconception which basically gets built into the guy student mind के सर इसमें भी होता है. That is not true. ठीक है, so this is basically marking the end of your chapter.